Hi folks, it's Glenn with some more of your final exam practice solutions. So I think I stopped at number 11 last time, and here we are with excuse me, number 12. This symbol means that there is an atom of element fluorine with one extra electron. This means there's an extra electron. It has 9 protons, right? So 9 protons. But if there's an extra electron, that means it has 9 plus 1 electrons, so 10 electrons. And this number here is the mass number. So if you subtract these, you'll get the number of neutrons. So that's 10 neutrons. Number 13. Oxygen molecules in a bunch of millimoles. This is a calculation problem, so I want the number of molecules. So I could start this with numbers of molecules. This is a good number of molecules, which is related to the mole. This many molecules are in 1 mole, okay? And these are oxygen molecules, molecules of O2 in 1 mole of O2, all right? And now they're giving me a number of millimoles. So milli means thousandths, so I'll multiply this by 1 mole of O2 is 1,000 millimoles of O2. I expect you to memorize the fact that milli means 1,000th. You could also say 1 times 10 to the minus 3. Instead of saying this, you could say 1 times 10 to the minus 3, or 1,000th of a mole is 1 millimole. It would be the same thing. But I prefer my way. You can do it your way, whichever way you like. All right, so moles of oxygen are canceled. Millimoles are not canceled, but millimoles do appear in this problem. 5.01 times 10 to the minus 4 millimoles of oxygen. So 5.01 times 10 to the minus 4 millimoles of oxygen. Yeah, this was oxygen. These millimoles cancel out. Everything is canceled except for the molecule, so the answer is going to be in molecules. The answer is going to be some number of molecules of oxygen. That's a no. And I bring out the old calculator, bring it out, brush the dust off a little bit there, and whoops. And I used the scientific notation button. It is the best way to do these types of problems. Use the scientific notation button. And then I multiply everything on top, and the stuff on the bottom, I just divide. And I got 3.02 times 10 to the 17th. It's 3.02 times 10 to the 17th molecules of oxygen. And that's a lot of molecules. Does that make sense? Yes, it does make sense, because there are a whole bunch of molecules in a mole, and this is 5. This is some very tiny number of millimoles, but this number still is much smaller than this number. So this makes sense, and there are 3 significant figures, 4 so the lowest number of significant figures given here is 3. So my answer is also 3 significant figures. Number 14, the density of air. So let's see. The density of air is some given amount, and the temperature of air, the temperature in the room is some degrees Celsius. The room temperature, and the room measures this length and this length and this length, this length and width and height. So what do you do? Well, we have the density, and we have the volume. They give us the room measures this length, this width, this height. So assuming the room is a cube, since they only gave us, assuming the room is rectangular, since they only gave us 3 numbers here, we can calculate the volume. The volume is length times width times height. And the length of this is 4.10 meters, and the width of this is 12.2 meters, and the height of this is 2.25 meters. This here is not chemistry. You are expected to remember this from any random math class from your past. Length times width times height, the volume of some rectangular solid. Now, I get here the answer in meters cubed. 112, well, there are only 3 significant figures, so 113 meters cubed. Can I use this to find the mass of air given this density? Not exactly. See, this density has dm cubed, not m cubed. So I'm going to convert this to dm cubed so that I could use it with this density, dm cubed. So let me do that now. So right here, I know that in 1 meter there are 10 decimeters. Yes, I expect you to remember this. This will not be revealed to you on the final exam. There are 10 decimeters in 1 meter. Okay, and this whole thing is cubed. All right, that means this 10 is also cubed. Right, so this is meters cubed. Cancel those meters cubed, and so I get 113,000 decimeters cubed. Okay, that's the volume of the room in decimeters cubed. By the way, this is not for the exam, but 1 liter happens to equal 1 decimeter cubed. That's the definition of a liter. Okay, now I'm going to calculate the mass. So I have 113,000 decimeters cubed, and I know that in 1 decimeter cubed, this air weighs 1.29 grams. Decimeters cubed cancel, and so I get the quantity of air, and it is 145,770. Okay, this is the answer that will be accepted. This answer is not accepted because they want the mass of air in kilograms. So I change this to kilograms by moving the dot over to the left 3 times. So I get 146 kilograms, 3 significant figures because they gave us also 3 significant figures. There are only 2 significant figures here, but we didn't use the temperature. Nobody cares about the temperature in this problem. That's just extra information that you don't need. Now this answer is accepted on the final exam. I know that WebAssign would be a little bit pickier. WebAssign would not let you round off to the significant figures right here. WebAssign would force you to keep this entire number, which was 112750 or something like that, and they would have you round off only at the end. So let's see what happens in that case. 113 times 1. This would be 4.1 times 12.2 times 2.25. So over here, this wouldn't be 113 meters cubed. This would be 112.545. So I'm doing this so that you can see the other answer that would be accepted. All right. So the answer here would be 112,545. So this isn't 750. Sorry, this is 112,545. All right, so there's 112,545 right there, multiplied by 1.29, and we get 145. So the answer, if this were WebAssign, the answer would actually be 145 kilograms. On the final exam, either answer will be accepted. You can be very accurate with the significant figures by only rounding at the very end of the problem, or you can round in the middle of the problem the way I prefer to do and get this answer. Either answer will be accepted. Okay, so now it's number 15, chemical formulas. Nice clean piece of paper here. Okay, now the chemical formula for ammonium sulfate is, here, this is the ammonium ion. You are expected to memorize the polyatomic ions. This is ammonia. This is ammonium, right, with 1 positive charge, right? And this is the sulfate ion with 2 negative charges. So to make them into a formula together, remember this number goes there, right there, and this number goes right there. Right. So NH4, but it looks like 42, so you need parentheses. And SO4. This is a 1, so 1 goes out here, but you do not need to write the 1 in a chemical formula because the fact that you're writing the formula already means 1. This is a capital O. It's very important that this be capital S and capital O because this means something else. It doesn't mean sulfur and oxygen. All right, that was ammonium sulfate. Let's look at nickel 4 phosphate. Nickel 4 is this guy, and phosphate is this girl. They could both be girls. It's okay. And then I'm going to move this 4 over there, this 3 over here, so it's nickel with a 3 there, and phosphate with a 4 there. Right? And calcium hydroxide. Calcium is calcium 2+. I expect you to remember that calcium is one of the atoms for which you can easily know the charge because it is in group 2, therefore the charge will be 2+. Okay? That will not be given to you on the exam. The periodic table will be given, but the fact that you can use the periodic table to find charges of ions will not be given. You have to know that yourself. And the other one is hydroxide. You must have memorized hydroxide with 1 minus charge. And so together they make calcium hydroxide, like this. And now, number 16. Write the balanced equation for this reaction. Luckily for you, folks, there are no redox equations to balance on the final exam. I thought there would be because I saw it on the WebAssign, but no, there will not be any redox equations for you to balance on the final exam. But there will be regular equations like this one in number 16. Magnesium, here's magnesium, combines with oxygen, here's oxygen, to make magnesium oxide, So to balance this, I need a 2 here and a 2 here. Now it's balanced. That's it. It's best if you also include the states of matter. So this is solid, this is gas. Any metal is usually a solid, except for mercury, which is a liquid. This is magnesium oxide. Any ionic compound is usually a solid. Okay. How could you have known that the oxygen is O2? I expect that you already know that oxygen is O2 from doing problems, but just in case you don't, I will show on the exam. Anytime there is a substance that is given with no formula, and you are expected to know the formula, if it is not something for which you've learned the rules, for example, magnesium oxide, you know how to write the formula for magnesium oxide. But oxygen, you do not. You might not know because there's nothing about the name oxygen that says that it should be O2. So for such things like oxygen, I will reveal the chemical formula for you on the exam. Okay, it will be there in the question. In fact, let me show you how I will do that. That was number 16. So, like this. Like that. And save. Okay, so that was 16. Let's go to 17. 17. Oxidation numbers for this equation. Okay, so it's the same equation, but the oxidation numbers are going to be, for a pure element, the oxidation number is 0. This is a pure element, it's oxygen with nothing else, oxidation number is 0. This is an ionic compound, so the oxygen is first, it takes -2, and the other things are next. If this is -2 and the total charge is 0, then this must be +2. We don't care about the coefficients here, folks. We only care about each element's oxidation state or oxidation number. Oh, okay. That was actually number 17. Okay, that was number 17. Now number 18. Which one is the oxidizing agent? Okay, now let's see. Who got oxidized and who got reduced? Mg went from 0 to 2, so this got oxidized. Oxygen went from 0 to -2, so this got reduced. Remember that oxidation means losing electrons. So oxygen is losing. Reduction is gaining electrons. Oil rig. So who gained electrons? Well, this oxygen gained electrons because it went from 0 to -2 oxidation state. This magnesium lost electrons because it went from 0 to +2. You get a positive charge if you lose electrons. So that means Mg got oxidized. The thing that got oxidized is not the oxidizing agent. The other thing is the oxidizing agent. So O2 got reduced. Actually, you can just write the atom. Whether you write the atom or whether you put the 2 or not, both are going to be right, but you just have to identify which element got reduced. So if O2 got reduced, if O got reduced, then O is the oxidizing agent, because the oxidizing agent gets reduced. And if Mg got oxidized, then Mg is the reducing agent. This comes from your textbook section on oxidation numbers. Okay, so that's it for number 18, 19, 20, and 21. Let's take a look at number 22. Nice clean paper here. Okay, number 22. A balanced equation with states of matter for lead nitrate and sodium phosphate. All right. Lead to nitrate. So this is a solution, so it's AQ. Sodium phosphate. This is also a solution, so it's AQ. So how do you know what's going to happen in the chemical reaction? Well, these are both ionic compounds, and so they will do the double displacement. This Pb will go with the phosphate. This sodium will go with the nitrate. So I'll have sodium nitrate. I'll have lead phosphate. This was lead 2, so it goes like this. So O should be capital. All right. So let me clean that up a little bit. Okay. That's what we get. Now, is this a solution or is it solid? You must consult the solubility rules again. Do you remember this? The solubility rules will be available for you on the first page of the quiz. This happens to be the case that phosphates are usually not soluble. Phosphates with transition metals like lead are not soluble, and so then this is a solid. It's important that you write the solid there, the S for solid. And it's important that you write on the other ones AQ for solution. The reason why it's important is because it says in the problem AQSLG. You have to write those to identify the states of matter. Okay, now number 23. I'm going to use the same equation and write the complete ionic equation for it. Remember this? Everything that's AQ gets separated. So first, oh wait, I'm sorry. I didn't balance this. So this is not correct until you balance it. I'm sorry about that. So I got 3 leads. Now I have 3 leads here. I got 6 nitrates. So 6 nitrates, 6 sodiums. Okay, now it's balanced. So this is the correct answer for that problem, which was problem number 22. Now I'm going to write the complete ionic equation by separating all of the things that are AQ. So I have 3 leads. I'll do this in a different color for you. Six nitrates, because there are 2 here and there are 3 of the whole thing. So 6 nitrates. Okay, we have 6 sodiums. and I have 2 phosphates. Okay, and that makes, draw the arrow for meaning yields, 6 sodiums, that's in solution still, AQ. And 6 nitrates. And one of these guys, but it's solid, so it does not get separated. Oops, did I say AQ? I meant solid. Okay, so that is the total ionic equation. Now I'm going to cross out the spectator ions. This guy shows up in the reactants and the products. This guy shows up in the reactants and the products. So what I have left here, I'm going to rewrite this. This is the net ionic equation. It goes oops, sorry. I'm drawing things that are not correct here. Okay. Okay, so yes, this is correct. So that in green is the net ionic equation. That was 24. Okay, for 25 through 30, I will make a separate video. Thank you.